Hello and welcome to C++ Weekly. In this episode, I want to talk about the strange idea of constructing lambdas on the heap. What does it mean? What would the use cases be? And is it even possible? Be sure to check out this video description for upcoming classes, workshops that I might be giving in an area near you or at a conference near you. This is the minimal form of a lambda. This is a lambda that has no captures, takes no parameters, and returns no value. And I can call it, and it does literally nothing. It can't do anything. What is this exactly? This lambda thing is a closure object, and it is equivalent to something kind of like this, which is a const_expr void call operator overload in a type that was constructed for me by the compiler. Would I ever want to create this thing on the heap? And it turns out I can create this thing on the heap. If I really wanted to, I can say create me a new object of the type of this lambda. And I can invoke the thing. Let's make it actually do something so that we can see it's doing something. We should be able to see that main is going to return 42 up here in the disassembly. Yes, main returns 42. Why? Why did I do this? What might possibly be the use case for it? When I first started planning this episode, which was now several years ago, the general use case that I had in mind is, what if the lambda is big? Now by big, I don't mean lots of lines of code. That's irrelevant. What I mean is, does the lambda have a large state? Or more to the point, does it have very large captures? So I have my big lambda and it's going to return 0. I say big lambda. How big is it exactly? Well, I don't think we're exactly allowed to reason about this, but we know that it has to be at least 4096 bytes because the size of an int on all modern platforms is a 32-bit integer, which is 4 bytes, and I asked for 1024 of them. That's 4 times 1024 is 4096. It's 4K. So maybe I want to create this lambda on the heap instead of creating it on the stack. I want to maybe try to do my lambda on the heap trick that I just did down here. So I'm going to do new decal type of this thing. This is my lambda thing. So go ahead and create me a new one, please, compiler. And I'm getting a compilation error. Use of deleted function. What function has been deleted? The function that has been deleted is the default constructor for the closure type, for the lambda, the thing that the compiler generated for me. The only lambdas that are default constructible are the ones that don't have any captures. So there's no useful thing that I can do to actually construct a lambda on the heap. I can create what amounts to a function pointer on the heap because this is an empty object with a call operator overload. I can't come up with a meaningful reason to do this. The closest that I have been able to get so far is to say I want to go ahead and create this big lambda. And then for some reason, I want to move it onto the heap. I can actually do that. I can get the type of this thing, which we already saw is going to fail to compile because I'm trying to default construct it, but I can pass the constructor the big lambda itself. And our lambdas are going to by default be movable. Now this thing is really big, which means it has lots of data on the stack, and we're not going to probably gain a whole lot by moving these values because that's just going to become a bit copy anyhow. But I can do this if I really want to. The takeaway that I had from this when I was working on this was to actually just go ahead and create the dang thing on the heap in the first place as a user-defined type that looks an awful lot like a lambda. So as I said, this is just a type with its call operator overloaded. Then in this case, I would say my L here equals a, and we're going to use make unique instead of new this time. I was just trying to prove a point earlier. Make unique of the lambda type. And now this is something that I can call. It would be automatically cleaned up when the object goes out of scope. And I have created this large callable object directly on the heap, if that is something that I really wanted to do. So there you go, lambdas on the heap in a way. What utility does this have? I don't know, but you can comment and you can tell me what kind of utility you think you found in this code. Thank you for watching this episode of C++ Weekly. I'll say this did not go how I expected it to when I planned it. I thought, oh, I can obviously show a way to create a lambda on the heap, but here we are. So be sure to subscribe and check out future episodes like this one.